So the first setting is called threshold. Threshold is pretty straightforward and easy to understand. What it does is it tells the compressor when to start compressing. So here in my simplified waveform signal, I have put a red dotted line to represent a threshold level, and that level set in decibels. Let's say you set it to minus 20 dB or minus 30 dB. The lower you set your threshold, the more of the signal it will cover. But as you can see, going back, I've got two different thresholds setting here. So let's look at the first one. What you can see is any part above the threshold is the part of the signal that is going to be compressed because it is too loud. You're telling the compressor, anything over this threshold is too loud, you need to compress it. Anything below the threshold is fine, don't mess with it. So that's very oversimplified look of how a compressor works, because there are other knobs that can impact how the compressor behaves in spite of the threshold level and the ratio setting that you set. But I'm not going to go into that. I'm just going to do straight up threshold and ratio. So now you understand what the threshold does. It tells the compressor when to compress. Anything over the threshold gets compressed. Anything beneath the threshold is left alone. And the lower you set your threshold level, the more of your signal is going to get compressed. So in this example, everything in my signal is now above the threshold. Therefore, everything is going to get compressed by the compressor. I'm now going to talk about ratio, which is the second compression setting. I just talked about threshold, which tells the compressor when to compress. The ratio tells the compressor how much to compress. So this is the part that I wish someone had explained to me. So ratios are always described as a number n to 1. So I'm going to create an example of 3 to 1. I've got a ratio of 3 to 1. So in the number n to 1, so every n decibels over the original signal that exceeds the threshold, so for that number of decibels that goes over your threshold, only 1 decibel is going to be allowed to exceed the threshold in your compressed signal. Let me show you what that looks like. So here I've got my threshold level, and now you can see I've added tick marks to my graph, right? These tick marks here will represent 1 decibel each. So if you look at the signal, it's about 3. Don't laugh at my tick marks. The peaks here are about 3 decibels over the threshold. So in my example of a ratio of 3 to 1, for every 3 decibels over the threshold, the compressor is now only going to allow 1 decibel to exceed the threshold. So what does that do to the signal? Okay, and don't laugh at my compressed signal. I know it's drawn very, very badly. But so now I have this green compressed signal, which represents what happens to my audio after compression. And you can see that, where it originally exceeded the threshold by 3 decibels, it's now only exceeding by 1 decibel. So that's the 3 to 1 ratio in action. And what that effectively gives you is 2 decibels of gain reduction. So this right here, the difference between here and here is 2, right? So the thing to understand about ratio is the larger the ratio, the more compression you're going to get, the more gain reduction you're going to get.